Hello guys, welcome to my YouTube channel. So in this video, we're going to learn about the potential energy diagram for N-Butane. So while drawing this energy diagram, I'm going to use the conformation, that is the standard conformation, Gauge conformation, anti-conformation, and the eclipse conformation. Now, N-Butane is, we have 4 carbon atoms bonded to hydrogen atoms. So we are going to do the relation about the carbon 2, carbon 3. So this is the first carbon, second carbon, third carbon, and the fourth carbon. So we are going to do rotation about this particular point. Now we are going to view it from this side. So when we view it from this side, we are going to have this first carbon, then this one is going to be located at the back. So while drawing it, you can simply draw it this way. We are going to have this is the outer carbon, this is the carbon here. Now this carbon is bonded to this methyl group. So it's bonded to a methyl group and 2 hydrogen atoms. Hydrogen atoms. Then this carbon here, now I'm going to represent it as the outer one. It's bonded to a methyl group and also 2 hydrogen atoms. But remember, we are starting with the least energy one, the one with the least energy. So when you want to draw the one with the least energy, you make the high priority groups to be on opposite sides of each other. So you have a methyl and a methyl group. They are the priority groups with respect to the carbon 2, carbon 3, the carbon atoms. So we are going to put the methyl group here so that they are opposite. These are the priority group. That's the methyl group on the other carbon. Then it's bonded to 2 other hydrogen atoms. So this is the one with the least amount of energy. It's the most stable. Yeah. So we're going to rotate this one so that we get the same diagram after rotating it until we get, okay, this methyl group should be found here and this one should be here. So we want to draw all those rotations. So let's start. We're going to start with this one, then let's draw the next one. So I'm going to keep this one constant, the one facing away. I'm going to keep it constant so that we rotate the outer one. So let's keep it constant. So it's going to be a methyl group and 2 hydrogen atoms. Then we're going to rotate this one 60 degrees, so that it comes here, this one comes here, this one comes here. So let's rotate it. We're going to have a methyl group there. Hydrogen and another hydrogen. That is our second structure. Let's get to the third one. We're still going on with the rotation. We're going to keep this one constant, just the way we did in the other one. Hydrogen, hydrogen. Then now the methyl group comes here. Hydrogen here, hydrogen there. Then we are still going on with the rotation. Let us rotate it again. The methyl group is still constant. Hydrogen atom. Then the methyl group is going to come here. Right. Then we proceed with the rotation. We want to make sure that we get the same structure, just like the one we started with. This metal should be here, and the other one should be down there. Now, we are going to rotation. This one is constant. Hydrogen. Then now the metal comes here. CH3. The rotation is 60 degrees clockwise. Now, that's it. So this one is not here yet. So we still continue the rotation. So we get it again. Then now the metal comes here. As this. Yeah. Then now you see we're almost here. So we rotate one more time. This one is constant. Bonded to hydrogen atoms. Then now our methyl comes here. Hydrogen here. Hydrogen here. Now you see we have the same structure just like the one we started with. So we have rotated it and to complete condition. So with this, we want to draw a potential energy diagram. But first, let us classify them as gauge and anti-conformations, so that we may get to know the energy each one of them contain. Now, this is the starting point. Now, we started with this. So this is number 1. These are number 2. These are number 3. And number 4. And number 5. And number 6. And number 7. Mostly the values are 7. Yeah. So let me draw this the other side. I'll do this first, drawing the potential energy. Let me go to this side. This is our first one. Then you curve. There must be an opposite sides. There's an edge. Yeah. So this is the most stable. So when it is the most stable, it has the least amount of energy. So this is number 1. So let us see. You know how the conformations look like, staggered, eclipse, So let us see. We are going to group them based on which one is staggered and which one is eclipse. And eclipse they are more stable as compared to the staggered. I mean, the staggered are stable as compared to eclipse, but eclipse have higher energy as compared to the staggered. Now, let's see. So our number 1 is staggered one. So when it is staggered, it is most stable, but that's the least amount of energy. So let's keep there, least. And this our number 7 is look like number. I mean that's our number 1. Look like number 7. So they have the same amount of energy. And both of them have the least energy. So we are through with those. So let's come back here. Let's group these ones as eclipsed or staggered. So this one is eclipsed. This one is staggered. This one is eclipsed. This one is staggered. This one is eclipsed. And remember, eclipse have a higher energy as compared to staggered, even though staggered are more stable as compared to eclipse. So let us see. Now, we have eclipse, staggered, eclipse, staggered, eclipse. Just as I said, eclipse have higher energy. So, we're going to see among these eclipse, which one has the greatest amount of energy, the highest amount of energy. Now, we have eclipse, eclipse, and eclipse. So, let us see. What's the decrease between the higher priority groups? So here, about 20 degrees. What about here? So it's 0 degrees. What about this one? What's that? 120 degrees. So the one with 0 degrees has the highest amount of energy. So I'm going to say highest. So when drawing the potential energy graph, we're going to see it at the topmost part, so it has the highest. Then this one and this one, the difference or the degree of rotation between the two high priority groups are the same, 120 degrees. So they have the same amount of energy. So we can simply say, and put it this way. So that's put there. Same. So that's our number 2 and number 5. Yeah. Now we draw number 5 for the same amount of energy. But remember, they are elliptical formations, so they have a higher energy compared to all these staggered we have here. So let us now arrange the staggered, which one now has the highest amount of energy. Among these staggered. So there are only 2. We have 1 and 2. Let's see the degrees between the two. Yes, 60 degrees. 60 degrees. What about this one? Also 60 degrees. So they have the same amount of energy. So that is our number 3 have the same amount of energy. So simply let me just let you send. Yeah. And just so that same not get confused. Okay, now let's now draw the potential energy graph. So here's the rotation. Then this side you have the potential energy. So let's get started. So what's our first? Our first was this one, just the least amount of energy. And number 7. So it's going to be at the bottom. Just pull it this way. It will be the bottom. Then you go to the second. The second has the same amount of energy with. This is the sixth. The second and the sixth have the same amount of energy. But remember the third. This is the second. Third has the same amount of energy as fifth. Then you have the fourth at the highest. So let us draw for the second. Let us put it there. Then we're now getting to the third. So the second has a higher amount of energy as compared to the third because it is eclipsed. Well, this one is static. So automatically this one will have to put it a bit higher. It will have to come down. Then we cannot yeah, so we can say these are second, these are third. The second is eclipse. That's why it has a higher energy than the staggered. So then you go to number 4. Number 4 is the highest. This is the third. It has a least amount of energy as compared to the second. So the fourth has the highest. So it goes highest. Yeah. So that's the number 4. Then we get to number 5. Number 5 has the same amount of energy as number 3. And number 3 is here. So come on, get it here. I think I'm correct. Yeah. So same level. Now these are number 5. You have the same amount of energy as number 3. Then we are going to number 6. What's the number 6? Number 6 is here. These are 5 and this 6. 6 has the same amount of energy as 2. And here is 2. So 6 has the same amount of energy as 2. Right. So this is our number 6. Then we go to number 7. Number 7 has the least amount of energy. It has the same amount of energy as the first one. And the first one is here. So it has the least amount of energy. To give you the same level. Alright. So these are number 7. Number 7. So this is now the potential energy graph for the N-Butane. So just manipulate this information, keep it, and remember to be very accurate while drawing these things because once you make a mistake, you automatically get the wrong answer. So if you follow the same procedure, you can now solve as many as possible, and you now come up with the correct graph. Otherwise, I wish you well, and make sure you subscribe to my YouTube channel for more videos. Thank you.